So as we move into inverses, I do want to point out just a little simple example of inverse thinking. A lot of times you'll attach a bolt to a piece of wood or something to hold something together. So if I just kind of think of this as a piece of wood that the bolt's going through. So for this to happen though, one things we have to do first is if you have this bolt, you're going to have to hold it together. A lot of times we have what's called a nut. So this is your bolt here. You have your nut. This is called a lock washer. Has kind of a funny little thing that kind of keeps it from backing out. This is just a regular flat washer. So we'll call this lock washer 1, flat washer 1. And then we have a lock washer 2 and a flat washer 2. So notice that as far as the sequence goes, you'd have to put, first thing that have to happen is you'd have to put the lock washer 1 on. And then you'd have to put the next thing you'd have to do is put the flat washer on. So that would happen. Once you put those two on, you would then push the bolt through a piece of wood. And then on the other side, the way this works is you want the flat washer against the wood. So you would want washer 2 against the wood. And then you would have your lock washer 2 would go here. And then finally, you would hold this all together with the net. So the net would go on last here. So keep that in mind, you've got your bolt. And then you attach your lock washer 1, lock washer 2, push it through a piece of wood, flat washer against the wood as well, lock washer there, and then the nut there. So that would be how you would put it together. So that would be your order. This would be, the bolt would be like the first thing. So you'd have the lock washer 1, flat washer is the second move. The third move is to push it through a piece of wood. The fourth move is another flat washer. The fifth move is to do a lock washer. And then the sixth move would be the putting the nut on and tighten it all together. So notice that if you want it, this is the process that you would be doing to put it all on. Now, to take it off, notice that the last thing we did is actually going to be the first thing off. So notice that the nut would be the first thing off. Then we would take off the lock washer, would come off. And then the third thing we would do is the flat washer would be removed. So the flat washer 2 would be removed. Then the wood itself would be removed. This would be the fourth step, pulling this out of the wood. And then the next thing you would be doing is the fifth thing would be taking off the flat washer and then removing the lock nut washer. So that would be kind of the process. So notice that you have to pay attention to the orders. So order on and order off. That's very, very important to us as we move forward. So we have these concepts of putting stuff together. We have this concept of removing stuff, and there's just backwards thinking that goes with that inverse thinking. So if we look at our first function, f of x, we have 2 times x plus 6. If I follow the order of operations, the first thing that's happening is we're multiplying by 2. And then the second thing we're doing is adding 6. If I want to reverse this process, if I want to go backwards, instead of adding 6, the first thing we need to be doing is subtracting 6. And then the next thing, instead of multiplying by 2, we want to divide by 2. So if we take a look at that, what this would look like is we start with x, and we would subtract 6, and then we would divide all that by 2. That's what the inverse would look like. So we use this notation to represent the inverse. So if you follow the process, I multiply, then add, the inverse should be subtract and then divide. So it kind of look like that. So if we look at these two functions up here, we have 2x plus 6, and we have this 1/2 x minus 6. Are these inverses of each other? Well, notice that multiplying, if I find the order of operations, you would be subtracting 6 first, and multiplying by half is the same thing as dividing by 2, so these would be inverses of each other. Now, one of the things we pick up on is if two functions are inverse each other, what has to be true is this: f of g of x has to equal x, and g of f of x has to equal x. So if I use composite functions, I can prove that these two functions are actually inverses of each other. So if I know what f of g of x is, I know what g of f of x is. If they both give me x, then that means that f of x and g of x are inverses of each other. Well, I can already kind of tell that these are inverses of each other because g of x is reversing what f of x is doing. So as I move forward in this problem, I already kind of know that these are both going to be x, but let's go ahead and play it out anyway. Let's do f of g of x to start with. So if I want to do f of g of x, notice that g of x is actually the 1/2 x minus 6. So this becomes f of, try to make that a little bit cleaner. A little worse there. There we go. So we have f of, and then g of x is actually that 1/2 times x minus 6. And then what we want to do is substitute the 1/2 x minus 6 into the f function. So this becomes then 2 times the quantity, and I'm going to replace this x here with what g of x was. So that means this 1/2 times x minus 6 goes in place of x, and then we add 6 from there. So if I do this math, notice that 2 times 1/2 is just 1. 1 times x minus 6 is x minus 6. So this is x minus 6 plus 6, which is going to give me x. So f of g of x does give me x. So if I want to evaluate g of f of x, what we pick up on is f of x is the 2x plus 6. So we're going to have g of, and f of x is 2x plus 6. That's what's going to go in place of x in the g function. So you're going to have this 1/2 times then, and then this 2x plus 6 is going to go in place of this x up here. And then we still got to subtract 6. So it kind of looks like that. So what we pick up on is, if I do the math, we do what's inside the parentheses, the 6 and -6 will zero out. That gives me 1/2 times 2x. And 1/2 times 2 is still just 1, and 1x is just called x. So we do have g of f of x equals x. So by definition, if f of g of x equals x and g of f of x equals x, so if these composite functions equal each other, then that means the f and g are inverses of each other. So this would be yes. So again, this is the key. If f of g of x and g of f of x are both equal to x, then the two functions are said to be inverses of each other. That's kind of our little definition here. But we can also kind of tell by looking at them, they are inverses of each other. So we can draw the conclusion that they both have to equal x as well.